All right. So once again, sorry, Trip, they just told me to start recording. We're a little bit into the lesson. You're going to still use your D to mark that middle line for tangent and cotangent. You're still going to go up A and down A and mark that line, right? You're going to find, actually, period is different also. Let me talk to you about period. Think about the sine curve as you go around the unit circle. What happens in the first quadrant with the unit circle? What are its values? Positive, positive, negative, negative. So it took you an entire 360 or an entire 2 pi to complete the whole period, didn't it? Right? Think about cosine. What happened? Positive, negative, negative, positive. Took you a whole 360 to go through that cycle, right? Positive, negative, negative, positive, positive, negative, negative, positive, positive, negative, negative, positive. What about tangent? Positive, negative, positive, negative, positive, negative, positive, negative. How many degrees did it take you to get through the whole cycle? Just 180 or 1 pi. Because I got through all the positive negatives, and then I did positive, negative again, positive, negative again. But if you think about the pattern, plus, plus, minus, minus, plus, plus, minus, minus, for sine, took a whole 360. Plus, minus, minus, plus, plus, minus, minus, plus. Whole 360 to get to cosine. Plus, minus, plus, minus, plus, minus, plus, minus. That only took 180 or a pi. And that's true for tangent and cotangent. So when I'm doing period, instead of saying 2 pi divided by b like I did with sine and cosine, you can see down here, it's pi divided by b. Now that's true for both tangent and cotangent. Tangent's the only one that has that phase shift, is the middle of my period. So you know how you've been putting a dotted line for phase shift? What's gonna happen to you when you find your phase shift on tangent and you come up here and you go, all right, there's my phase shift right there, and you come in here and you put a dotted line there? What are you probably going to mistake that for? An asymptote. So don't do it. Don't put a dotted line there. Just mark your arrow and go, oh, now it's fine to do that. Guys, it's fine to do phase shift right here for cotangent. And then for cotangent, mark 1 period over, and you'll have your asymptotes. It's fine to do that. But remember, for tangent and tangent only, make a little note, put an arrow or something, and then you're going to go half the period to the right, half the period to the left, and then you're going to put your vertical asymptotes in. Y'all seeing that? And that's going to give you your ladder with your 3 rungs or whatever, or your funny little H or whatever it is you need to graph. And then all you have to do is this to graph them. Once you get that in there, we already said that that middle point in between those and in between those, that very middle point will always be part of the graph, no matter what kind of tangent or cotangent graph it is. And we already said it's all right to be tan. Now, one thing we haven't talked about is, what is the A doing for me? Okay, and again, pattern recognition. It just so happens that this height, this A, that is the height of the graph halfway between this point and the asymptote. So whatever H you've drawn, go halfway in between there, and then go up to the A value. Halfway in between there, go down to the A value. And then you've got 3 points. All I got to do with those 3 points is draw a nice, smooth curve that is going towards the asymptotes, but smoothly through there. It's amazing how unsmooth graph I see. Like, I'll see stuff like this. They'll get all this in here, right? They'll mark their points, and then this stuff will happen. Every year I get this crazy, I don't even know what that is, right? Tangent curves, nice and smooth, literally. Sometimes they hardly even bend, just nice and smooth all the way through. No extra little wiggles in there, okay? But if you have the points in there, I doubt I'm taking off more than a half a point at best. just because I realize maybe your hand's like David or Charlie Vaughn, but whatever. Are you with me? So if I come over here, halfway between those, I'm going left up, halfway between those, left down, nice smooth graph. All right, and if it's a negative tan, instead of going up to the right, I go down to the left. If it's a negative cotangent, instead of going up to the left, I go down to the right. Instead of up to the left, I go down to the left. Y'all with me? Okay, so I put all that here. Again, D is the vertical shift. A isn't the amplitude. It's that height I was just talking about, but I'm still going to mark it. I'm still going to set BX minus C to get the phase shift. But what's different about phase shift with these? For tangent and tangent only, it's the middle. Cotangent, treat it like sine and cosine. It's the beginning. It's the middle of the graph, and then period is not 2 pi over b. It's pi over b. You've got to remember that right there. And since it's pi over b, I take that, and if it happens to be tangent, I go half each way. But if it's cotangent, I just mark a full period and get the other asymptote. So let's graph a couple of these. I don't think you're going to have a whole lot of trouble. I'll come back to those. So I'm on page 70 down here at number 3. All right, so 70, number 3, let's take a shot. So first thing you want to do here is what? Down 2. So I'm going down. And that's my D value. I'm done with that. After that, what? Up 3, down 3. Because the A value is a 3. So I'm going to go up 3. Technically, it's not amplitude because amplitude is defined by how high or low that you go. And this thing goes up forever. But it is useful, so I'm going to mark it anyway. Now I'm done with that 3. And then what do I do? Find the phase shift. So I set that equal to 0. Subtract the pi over 2. Multiply by a half so I don't accidentally mess that up. And I get negative pi over 4. Now that is a location, not a length, right? So I need to go 1/4 of the way to pi left. Well, pi looks to be like 4 tick marks away, right? So I'm going to move one of those 4 leftward, and I am not going to put a vertical line there. Why? Because it's not an asymptote. It's not a beginning or end. It's a middle of the period because it's a tangent graph. So I make a note of where it is, and then I move on to find period. Now, period is defined as what? It's a length. So the length of the period is pi over b because it doesn't take as long to complete the cycle. And this b value is a 2, but because this is a length, you need to figure out how many tick marks it is based on this particular number line. Pi is 4 ticks, so a half a pi would be 2 ticks. Now, here's where you got to be careful. Remember, if that's the middle of the period and the total period is 2 ticks, what do? You go, yeah, that's right. You go a half of a period that way and a half of a period that way. So I'm going to come in here and do 1 tick mark to the left, up and down forever, 1 tick mark to the right, up and down forever. And those are my asymptotes. Now, do you see the ladder in there? And this is what kind of a tangent? A positive tan. Positive tans go up to the right. So once again, I know that in between the horizontal lines and in between the outer vertical lines, there's got to be a point there. That's true of all the tangent and cotangent graphs. But since I'm going up to the right, how do I use this A value? I go halfway in between up and then halfway in between down. Those are my 3 points. And look, it's hardly even going to have a bend on it. Just come down, hit that point, hit that one, and follow the other side. I mean, most of them, unless you have a really small A value, they rarely bend a lot. And most of my A values are like 2 or 3 or whatever. So it's going to be nice and smooth through there. And how many periods do we have? We always, I mean, how many periods do I ask you to graph? 2. Now, how do I mark the next period? Do I go over another half and a half? No. Once I know where it is, I can just move over one more full period. So once I have established my asymptotes, you're going to be marking asymptotes every 2 tick marks. So once I have that, I should be in pretty good shape to mark another 3 points and sketch this graph. And if you get a couple periods in there, I'm fine. You certainly don't need to do all of them like I think I did on my keys. Not too bad. So building off what you already know, I don't think it's horrible, but you do have to remember tangent and cotangent have different periods from all the others, and tangent's phase shift works differently. All right, those are the things you have to kind of lock in your head. All right, what about number 4? So I've got a cotangent curve. Starts out the same way though. So help me out. What first? So up 1. And then that takes care of that 1. Then what? Up and down 4. That takes care of the A value. And again, it's not technically amplitude, but we're still going to kind of use it. Takes care of the 4. At this point, I might have noticed that this is a positive cotangent graph. So I know that that thing is going to go up to the left. And then what do I need now? Phase shift. My phase shift, I can eyeball that and see that it's pi over 3 because I'm not going to have to divide or whatever. So I know the phase shift's positive pi over 3. So what represents 1/3 of the way to pi? Pi is 1, 2, 3, 4, 5, 6 tick marks. 1/3 of that would be what? 2/6 or 2 tick marks. So there is my phase shift right there. And this is not the middle of the period, right? It's like all the other ones is the beginning of your whatever. So I can, on this one, I can go ahead and mark the vertical asymptote right there. Totally can do that because it's not tangent. Phase shifts mark the beginning of a period on all the other graphs or the end of a period. And then what is my period on this? Yeah, it's pi over b, but since my b is 1, it ends up being just a pi. And how many tick marks is a pi on this graph? 6. So if that's 6 tick marks, remember that period is a length. When I say period, I mean the length of the period. So from there, I'm going to go 1, 2, 3, 4, 5, 6 to the right. Remember, we're going all the way up and down. And then I can also 1, 2, 3, 4, 5, 6 to the left. Orange in the middle is bothering me a little bit, but whatever. So now that I have this, can you see the 2 H's in there? Or the 2 ladders? So here's my first ladder I drew over here on the right side. I'm going to go to the middle of the horizontals and the middle of the verticals right there. And I'm going to mark that first point. And then how do I use this is positive cotangent. So cotangent is up to the left. So I'm going to go halfway in between that and that, which even though there's not a tick mark there, you can see it pretty easily, right? And I'm going to go up to A. And you're going to go halfway between that and go down to the A. Those are your 3 points. And again, start at the asymptote. And you're going to go nice and smoothly right through here and then follow the asymptote. Same thing again. Nice and smoothly. and that's cotangent. So the only real difference other than the actual look at the graph here was that your period was pi over b. The phase shift, everything else was done just like sine and cosine. Whereas tangent has those two differences. It's got the period difference, and also the phase shift is the middle, not the beginning or end, like everything else. That was with tangent. We good? All right, last two. Here's the great thing about graphing secant and cosecant. They require you to graph sine and cosine first. And if you have them graphed, super easy. Okay, so let's just say I was asking you to sketch the graph of some positive cosecant curve. A positive cosecant curve. So we're not going to get into what it is, but let's just say it was something like, this. So you have this y, you got some d value, it's positive, you got an a, but it's cosecant of some bx plus c. So you're looking at this graph. So here would be your process by which you do this thing. You see cosecant, and you know I'm just going to graph this. It's reciprocal, the sine curve. So just do it. You got to set it up. You got to mark the d value. You got to mark the a values. You got to mark your phase shift. You got to put off your period. You put the 5 dots in there that you need. Now, by the time you get that done, you will have some box that you are looking at. Let's just say that this was your box of your positive sine curve, and you had your 5 dots in there. Just ignore the blue. All right? So let's just say you had sketched everything, and this is where you currently were. You do not have to dot in the sine curve. You don't. The sine curve will not be part of this graph. You just need those 5 dots. Well, you need a couple more because you need 2 periods. But all you have to do to create a cosecant curve out of a sine curve are these 2 things. Wherever these middle dots occur, the dots that are on your D right here in the middle, those represent vertical asymptotes, or the locations of them. And if you're wondering why, if you think about the original sine curve, right? On the original sine curve, on your original sine curve, this was your y-axis and this was your x-axis, right? And your original curve looked something like this. You remember this? Original sine curve? Weren't these the places on the d value on the original sine curve where the curve was equal to 0? Well, where sine is equal to 0, what's cosecant equal to if it's a reciprocal? Undefined. Think about it. What is the sine at 0? You go to 0 degrees and you put y over r, or y over 1, and you get 0 over 1 is 0. But if it's cosecant, you put 1 over y, which is 1 over 0, which is undefined. So anywhere a sine curve would land there, a cosecant curve would be undefined. Well, that's true even after the shifts. So anywhere a sine curve, which is kind of what I've sketched, is a 0, a cosecant curve will have a vertical asymptote. So you come in here and you go, all right, vertical asymptotes, anywhere this little curve I've sketched for sine crosses my vertical shift, my d value. Just put in vertical asymptotes. And then all you have to do after that is you take the high places on the graph and to give you a visual, it's like you're taking scissors and you're cutting this thing in half, and you're taking that little parabola looking thing and you're flipping it up, except it doesn't just flip up a little bit, it continues to rise the whole way. So literally you're taking this little thing here and you're making it look like that. You're taking this little thing here and you're making it look like that. So once you get this curve sketched out, and all you got to do is a couple periods, once you get it sketched out, get your 2 boxes, right? Mark your 5 points. Like mark the 5 points All right. And then anywhere it crosses that D value, anywhere, put vertical asymptotes. And then all you have to do after that is take the high parts and make them go up like that, like a little mini parabola. It's not a parabola because parabolas keep getting wider and wider. These don't. And then go down right there. That's it. And the great thing is you do the same thing, whether it's positive sine, negative sine, positive cosecant, negative cosecant, positive secant, negative secant. The only difference is if you get to something like this, if I'm trying to graph a secant curve, you're going to use what? If I'm trying to graph positive secant, you're going to sketch what? Positive cosine. So you sketch the positive cosine curve. But it's still going to look the same, right? I mean, that looks like a sine curve as much as a cosine curve does. It's just different shift. So what do you do to actually get a secant out of this cosine? Once again, anytime it crosses, this would have been where that middle line was. Any place it crosses here, any of those, vertical asymptotes. I'm not going to do this whole thing. And then any place that has a high spot, make it go up. Any place that has a low spot, have it go down. And if you're wondering right there, well, how, I mean, is it like just straight, kind of real skinny, or is it really wide, like that? We're not worrying about that. We're just sketching. If I wanted to look really nice, I'd pull out my Inspire and sketch it. And you, again, need 2 periods. So as long as you have a bump up, bump down, or going up, going down, going up, going down, you're okay. Y'all with me? So that's cosecant, cotangent, whatever. That's all the rest of the 4. So if you go back to a practice, I guess that was my practice, wasn't it? Heck, we'll do one of the homework problems. Pick any one of these, not tangent, cotangent. I want to leave those 4 to you. Pick one of these. Tell you what, we'll just make one up.
6.
Why 6?
It's on the homework. And it's cosecant.
Yeah, but so is 5.
6.
You don't want the practice? You got a whole period tomorrow. I'm going to just make one up. Just so don't copy this down. You don't want the practice. Hey. So I'm just going to make one up. You tell me what to do. So don't put this down, but we're going to do, okay, so we're going to make this up. Hopefully the graph works well with what I'm doing. So let's just say we had, let's just say we had y equals -1 plus 2. Nope, not plus. Let's do a minus. -1 minus 2 secant of 2x minus, how about 3x minus pi? It's going to be a mess, isn't it? Nope, it's going to be good. Sticking with it. Okay, so tell me, where would you begin right here? Start with the D, -1. So I'm going down 1. Then what would you do? Oh, by the way, before I start thinking, to graph a secant curve, a negative secant, what will you be sketching right here? You will be sketching a negative cosine. That's what we're thinking. And then we're going to use that to get the negative secant curve. All right, so I've got the D in there. What's next? There's my up 2. There's my down 2. Next. Phase shift, set that equal to 0. And I get 3x equals pi, x equals pi over 3. Okay, so that's a positive value. I want to move to 1/3 of a pi. Pi is how many tick marks? How many tick marks is it? 3. So I want to move 1/3 of the way towards that pi. So that would be right there, 1 tick mark. So I want to go right there. That's my phase shift. All right. Now, again, right now I'm only graphing the cosine. So I'm not even thinking about a secant right now, or the negative cosine. So I mark that. What's next? What's the last thing I need? Period. So I need the period. And remember, period is a length. Right? This is my phase shift is a location. Period is a length. And that's 2 pi over b. Okay, wait a minute. What's 2/3 of pi? How many tick marks is that? 2, because pi is 3 ticks. So this is 2 ticks. It's going to be a pretty short little period right there. So I come in here 2 ticks to the right. So there is my box. I need 2 boxes. There's another one. All right, so if those are my 2 boxes, where would you mark points on these if I'm graphing a negative cosine? Where does negative cosine begin? Sine starts in the middle and bumps up and bumps down. Cosine starts either high and dips low, or low and comes high in the middle. Which one is this? Low and comes high. Okay, so I'm going to start low and low. In the middle, I'm going to be at the high, and I must cross right in between those. Now, I don't actually have to connect this and make a cotangent out of it. I don't. If you want to, if it brings you comfort, you can, but make sure it's dotted. If you make that solid, then I think that you think that that's the graph. Notice I've been doing dotted lines to help me think, but those are not part of the graph. It's the solid things that are part of the graph. So if you want to sketch it in there and go, all right, little dots going up and down, knock yourself out. And I can do this again, right? I'm going to go high in the middle, low at the end, cross in the middle. Now, really, what's important about this? What are the 2 things I do once I have this cosine curve to change it into a secant curve? Anywhere it crosses in the middle, I create what? Vertical asymptotes. So I got one there, 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 and there. And then what's the only thing I have to do after that? High points, follow the asymptotes up. Low points, follow them down. High points go up. Low points go down. And if you want to sketch more periods to make it look more complete, great. That's it. Let me show you what I'm looking around. I'm guessing about 3 or 4 are going to do this on a test. You're going to do what I did here, except some of you like to put the little dotted cosine curve in there. All right. So you're going to get this cosine or sine curve, whatever it is. You're going to get to right here. And let's come back right. Let's just say you've got it all plugged in there like this. And this is what's going to happen. You're going to go, oh, sweet, I got it in there. Now I got to create a secant curve out of it. And you're going to go high goes high, low goes low. High goes high, low goes low. And you're going to do that. And you know what I'm going to do? I'm going to go, asymptotes were supposed to be right here, and you crossed vertical asymptotes, right? Asymptotes are supposed to be right here, and you crossed vertical asymptotes. You only have to do 2 things to get this graph. You just missed one of them. All right? Don't miss half this problem because you forgot to put asymptotes in there. Now, I will say that if you really know what you're doing, I don't, like if you're like, all right, well, I know there's an asymptote there, so I'm just going to do that because I know that there was an asymptote there. And I know there's an, so I'm going to do that and that. As long as you're staying in, I don't need you to put them. But unless you can visualize that they would have been there, then go ahead and do that. It's going to help you. So I'm going to take a look at where they were supposed to be. If you're able to do it without writing them in there, great. But if you're not, just put them in there and make it really clear to me you know what you're talking about. What do you think? Trickiest question I put on a test. I'm spoon feeding it to you. You will remember. Right here. Determine an equation of an asymptote of determine an equation of an asymptote. I asked this question, and at least half the class does this. Oh, asymptotes of a tangent graph occur at the phase shift. 3x minus, maybe I put a pi in there, 6 pi. 3x minus 6 pi is 0. Solve, and I get x is 2 pi. And it goes, sweet, 2 pi. Asymptotes don't occur at phase shifts on tangent. Phase shifts are in the middle of the period. So what you just found here was the phase shift. What do I have to do with the phase shift to find the asymptote? I need to find the period, which is what? 2 pi over 3. And then do what? The period is, oh gosh, yes, my bad. Yes, period, pi over 3. And then do what? And then go half each way. So if I only need an equation of an asymptote, you could go half the period, half of that period to the right of the phase shift. So you could basically just add a half of a pi over 3 to this, or subtract a half of a pi over 3, and you would end up with 2 pi plus pi over 6. Can we find a common denominator there? So 12 pi over 6 plus pi over 6 would be, so at 13 pi over 6, at x equals, because it's an asymptote, I would have an asymptote. Does that make sense? Now, if I change this to cotangent, if I change that to cotangent, then what? That's a cotangent graph. Then what? Yeah, then that is what? Then that is the phase shift. So in that case, that would be the equation. You don't have to do anything to it, right? You can stop right there. You don't even need another period. But I normally ask the question not about cotangent, but about tangent or secant. And if you need to sketch it, just sketch a graph and then figure out where you are. That's probably the most missed question ever on this test. If you're like, that was easy, awesome, probably in good shape. All right, that's all I got. Remember, you can do this homework in class tomorrow, or you can bring something, but don't make whoever is covering this class angry, especially if I think we actually have a sub, but especially if it's a teacher that's covering my class. As a rule, we teachers hate covering classes. So take it easy on it.
altogether?